Okay, today we're going to look at the rational root test and the remainder and factor theorems. Both the rational root test and the remainder and factor theorems will help us find values to use for synthetic division and find factors of higher order polynomials. So let's get started. The rational root test provides all possible rational roots of a polynomial. Let's take, for example, this higher order polynomial of 2x cubed plus 3x minus 5. Using the rational root theorem, we're going to call the leading coefficient q and the constant p. The rational root theorem says that if we take the factors of p and divide them by the factors of q, we get all possible rational roots. Remember, p comes from the value of the constant, and q comes from the value of the leading coefficient. Our factors of p are 1 and 5, and our factors of q are 1 and 2. Now, our possible rational roots are going to be all the values, positive and negative. So if we take the first group, 1 divided by 1, we're going to get plus or minus 1. And then we take 1 plus or minus 5 divided by 1. Then we get plus or minus 1 divided by 2. And then finally plus or minus 5 divided by 2. These are the only possible rational roots that would be roots of the higher order polynomial 2x cubed plus 3x minus 5. They would also be our only possible zeros. The remainder and factor theorems are used to determine the remainder if we would divide a higher order polynomial by a possible root, and factors, so it would give us our factors since we would have the root, when a polynomial is divided by a binomial. Okay, so let's take a look at this higher order polynomial, 2x cubed plus 3x minus 5. And let's say we were trying to find out if x minus 1 was a possible factor. We would plug 1 in for x into the equation, and we would get 2 plus 3 minus 5, which would give us 0. That would indicate that, yes, x minus 1 is a factor of the polynomial 2x cubed plus 3x minus 5. Since the remainder is 0, we now know that if we divided 2x cubed plus 3x minus 5 by x minus 1, we would get a remainder of 0. By plugging the x value, 1, into the polynomial and getting a remainder of 0, the factor theorem tells us that x minus 1 is indeed a factor. Because the remainder is equal to 0. So here's another polynomial. And let's say we were wondering if x minus 6 is x minus 6 a factor. Well, we would find this out by we could tell immediately that this is not possible for x minus 6 to be a factor, because the only possible factors are going to be 1 times 5 divided by 1 times 3. So the factors of p divided by the factors of q, or plus or minus 1, plus or minus a third, plus or minus 5, and plus or minus 5/3. Since 6 is not one of these, then x minus 6 cannot possibly be a factor. Now let's say we took one of the possible factors, like x plus 1. Now, for the rational root test, does tell us that it is possible for negative 1 to be, or x plus 1 to be a factor, negative 1 to be an x value. But when we plug the negative 1 into the equation, or into the polynomial, we get that it equals negative 7. So, nope. X plus 1 is also not a factor. Now let's look at this example. Is x minus 1 a factor? Well, we can see from using the rational root test that yes, we can get 1 as a possible root. So therefore, x minus 1 can be a possible factor. We plug in 1 to the higher order polynomial, and we get 0. So yes, it is a factor. So, if you have any questions on this, because sometimes it can be a little bit confusing, because I keep using factors and roots, back and forth. But remember, if 6 is a root, then x minus 6 is the factor, because you're taking the x value, which is the root, and putting it into parentheses, so it becomes the opposite. And you're going to see how useful this is when you do synthetic division. Any questions? Ask me tomorrow in class.